Section 3.3, Measures of Relative Standing and Box Plots. Key concept. This section introduces measures of relative standing, which are numbers showing the location of data values relative to the other values within the same data set. The most important concept in this section is the z-score. We also discuss percentiles and quartiles, which are common statistics, as well as another statistical graph called a box plot. Now, basics of z-scores, percentiles, quartiles, and box plots. Now, a z-score, or standardized value, is found by converting a value to a standardized scale as given in the following definition. This definition shows that a z-score is the number of standard deviations that a data value is from the mean. We will use z-scores extensively in later chapters. So here's a definition. A z-score, or standard score, or standardized value is the number of standard deviations that a given value x is above or below the mean. The z-score is calculated by using one of the following formulas. Okay, so for the sample, the z-score is equal to the data value x minus the sample mean divided by the sample standard deviation. Or for the population, the z-score is equal to the data value x minus the population mean divided by the population standard deviation. Now you got to be careful with the order of the formula. So you got to make sure the data value is first. You're subtracting the mean and then dividing by the sample standard deviation. Now, what is the round off rule for z-scores? Well, round z-scores to 2 decimal places, such as 2.31. So you always round your z-scores to 2 decimal places. Now, the round off rule for z-scores is due to the fact that the standard table of z-scores, which is table A2 in Appendix A, has z-scores with 2 decimal places. Now, what are some of the important properties of z-scores? Well, a z-score is the number of standard deviations that a given value x is above or below the mean. Z-scores are expressed as numbers with no units of measurements. A data value is significantly low if its z-score is less than or equal to -2, or the value is significantly high if its z-score is greater than or equal to +2. If an individual data value is less than the mean, its corresponding z-score is a negative number, which means that it can be a negative or a positive number.